Hello, I'm Daniel, Varsity Landscaping's corporate trainer, and welcome to the Spreader Systems chapter. In this section, we'll discuss spreader operation, calibration, application rates, and proper distribution techniques. Understanding how spreaders work is important because granular pesticide applications are commonly used in turf and landscape management and are frequently covered on the registered technician exam. A spreader is designed to apply dry products such as granular pesticides and fertilizers. Unlike sprayers, spreaders are not designed to apply liquid formulations, solutions, or suspensions. One of the most important exam facts to remember is that spreaders apply granules. If you're asked which equipment should be used for a granular formulation, the answer is typically a spreader. There are two primary spreader types you'll encounter. Rotary spreaders are used for broadcast applications and large areas because they throw particles outward over a wide swath. Drop spreaders release material directly below the spreader, making them ideal for precise applications where accuracy is important. Both have advantages depending on the application. The registered technician exam often asks which equipment is designed for broadcast applications. Rotary spreaders, drop spreaders, and boom sprayers can all be used for broadcast treatments. However, hand dusters are not intended for broadcast applications and are typically used for spot treatments or very small areas. Calibration is one of the most important responsibilities of an applicator. Proper calibration ensures that the correct amount of product is applied, helps maintain label compliance, improves pest control results, and reduces waste. Before every application, spreaders should be checked and calibrated to ensure accurate product delivery. Several factors affect the amount of product being applied. Opening size, travel speed, and product characteristics all influence application rate. One thing that does not affect application rate is hopper capacity. The hopper simply determines how much material the spreader can hold, not how much it applies. When adjusting a spreader's application rate, the first thing you should adjust is the opening size. This controls how much material is released. Factors like tire pressure, handle height, and hopper size do not directly control application rate and should not be your first adjustment. Travel speed directly affects application rate. Moving faster results in less product being applied to a given area because you spend less time covering that area. Moving slower results in more product being applied. Remember this simple rule: decrease speed to increase application rate, and increase speed to decrease application rate. The best way to evaluate a spreader's distribution pattern is through field testing. Place shallow collection trays or containers across the spread pattern and compare the amount collected in each tray. This allows you to evaluate coverage, distribution, and overall application uniformity. Swath width refers to the width covered during a single pass of the spreader. Understanding effective swath width is important because it helps prevent skips and overlaps. Proper overlap ensures consistent coverage across the entire treatment area. A split application involves applying half of the product in one direction and the remaining half in a direction perpendicular to the first pass. This technique improves coverage uniformity and reduces the risk of streaking. It is a common recommendation for granular pesticide applications. Spreaders are designed specifically to apply granular formulations. Granules are generally considered ready-to-use products and are commonly used for turf treatments, weed control, and fertilizer applications. Understanding formulation types is a common exam topic. Let's look at a calibration example. If a spreader is calibrated to apply 2 pounds of product per 1,000 square feet and the treatment area is 3,000 square feet, how much product is needed? Take a moment to calculate the answer before moving to the next slide. The correct answer is 6 pounds. Since 3,000 square feet is 3 times larger than 1,000 square feet, simply multiply 2 pounds by 3. This is a common type of rate calculation found on the registered technician exam. Here's another common calibration question. You have a 4-foot drop spreader and need a 200 square foot calibration area. How long should the test course be? Think about the relationship between area, width, and length. The correct answer is 50 feet. Since area equals length times width, divide 200 square feet by the 4-foot width. This gives a test course length of 50 feet. Before moving on, let's review the key exam facts from this chapter. Spreaders apply granules. Hopper capacity does not affect application rate. Opening size controls output. Travel speed affects application rate. Collection trays are used to evaluate distribution patterns, and split applications improve coverage uniformity. In this chapter, we covered spreader types, calibration procedures, application rate adjustments, distribution testing, and split application techniques. These concepts are important not only for passing the registered technician exam, but also for ensuring safe, effective, and accurate granular pesticide applications in the field. Be sure to review these concepts before moving on to the next section.